Hey, how are you going with your algebra journey? We've got something happening now, haven't we? We've introduced letters to stand for missing numbers to describe patterns and solve problems. And what is that letter? Well, it's called a pronumeral. And what's it do? It's standing for some missing number. So we're going to have to look at how we're going to handle those. And what this presentation is about is building up some skills so that we can use A's and B's and P's and Q's, X's and Y's to describe the patterns that we see. Come up the top here, and if we've got 4 3s all added up, we say that's 4 lots of 3, and we could actually make it the number 12, 4 lots of 3. So if we're working in pronumeral land, B plus B plus B plus B, we've got 4 lots of B. We can't actually work out what B is. We've got 4 lots of it, so we just put 4B. We leave out the times sign. Okay, so what we're doing is trying to say, hey, what is a pronumeral anyway? What can we do with it? We can do the same sorts of things that we do with numbers, because pronumeral stands for a number. Okay, let's have a look at this. Some numbers here, 3 by 3 by 3 by 3. And this is the index or power laws. We say that's 3 raised to the power of 4. So there's 4 3s all multiplied by themselves. And so if we did it in B land here, B by B by B by B, we could also use that symbol, B to the 4th, excuse me. Okay, get the idea. Let's go down and see if we can build up a nice language in maths to describe what we've been doing. Okay, so we've skipped a little bit there, so just go back a little. And here's the idea. We leave out the time signs between multiplied quantities. So what we've just seen is 4 lots of B, we just say is 4B. Make it nice and neat. We write the numbers first. So we don't put B4, we put 4B. Okay, just a convention, little set of rules so that we're all on the same page with the way we're using our pronumerals. And where products contain 2 or more letters, we write them in alphabetical order. So you wouldn't write B times A, that would become AB. And it wouldn't be YX, we would say it's XY. If there were 2 numbers multiplied together and we wanted to work it out, and they're both varying, X is standing for some quantity that's varying and so is Y, so we would put X first and then Y, put them in alphabetical order, just so all of our stuff looks the same as everybody else's who's doing a bit of algebra there. Write in product notation 2 times 6S. Well, we leave out the times and just put ST because S comes before T in the alphabet, and we always have the number in the front there. Okay, just so we can compare with other people working with pronumerals. Okay, 4 times K plus M times 3. Leave out the times and put 4K plus, that's that plus there, M times 3 we put 3M. We put the number in front. Okay, 3 lots of R plus S. So the R plus S is times, but we leave the times out. Get the idea there. Okay, let's look at some more little conventions that we developed so that we're all on the same page. R plus R is 3 lots of R. Plus here, S plus S, 2 lots of S. 3 cats and 2 dogs, mate. Okay, something like that. We're collecting up the things that are the same as each other. D plus D is 2D. Take, that's that sign there, and what have we got here? A plus A plus A plus A, that's 4 lots of A. Okay, neat system, isn't it? It's a neat way of working with our numbers, but we don't know what, we're using letters, pronumerals, mate. Okay, so here's a big product here, and if we look at that, it's 8 lots of B by B could be called B squared, but we put that second, because A comes before B in the alphabet. A by A is A cubed. Get the idea? Just the same as working with numbers, because pronumerals stand for numbers. What are pronumerals anyway? Keep that in mind. That's the subject of this whole presentation now. K plus K, take 3 times D by D by D. K plus K is 2K. And take, and we leave the number out the front, D by D by D is D cubed. Getting the hang of it. Come down, I'm going to give you a go in a minute. Here they are. Some little examples here for you to have a go. So I want you to pause the presentation and try to do every one of these. As you do a few, toggle forward because the answers are down below here, and check it and then go back and do the next few. don't get them all wrong and find out too late. Okay, pause it, have a go at question 1 to 3. Let's go to the last two now, 4 and 5. Okay, and this little dude here, we're using shorthand notation to simplify the look of an expression. And we're doing it in a certain way so that everybody can compare their work and be using the same sort of system. All right, pause it, have a go at question 4 and 5. Let's have a look at the answers. Coming down now, here are the answers to 4A. Now the screen clippings here are from Hayes and Harris publications, so you should have that book handy by there to have a look in there. All right, let's go on with more of our new algebra language, working with pronumerals. What are pronumerals anyway? They just stand for numbers, mate. So here we are. Let's use some new terms here. A variable is a quantity which varies, and it's going to be represented in an expression by a letter or symbol, some unknown value. So we let a pronumeral stand for it. So here P is 2 lots of L, and L stands for some varying number, plus 2 lots of W. So the varying things in that expression, that equation actually, are P, L and W. Call those variables, things that can be replaced with different values for them. Expression. This is some algebraic form consisting of numbers, variables and operation signs. What have we just been doing? 2x plus y maybe take 7. And 2 times a plus b on c are 2 different expressions in algebra land. What about an equation? Maybe you can see here equating. An algebraic form, which is what we had before, an expression which has got an equal sign in it. So here's an expression, but it becomes an equation because it equals -1. Here's an expression, it becomes an equation because it equals -4. And I'm going to ask you the burning hot question here. Can you solve those? At this stage in your algebra journey, you should be able to unpack your present there and get back to the unknown, if you've been watching the earlier presentations. Okay, let's look at another way of explaining what we're creating here, or what we're finding. Terms. Algebraic forms which are separated by a plus or minus signs, and the signs are included. So here's a term, 3x, take 2y is another term, plus xy. It's the pieces that make up the expression, isn't it? And we include their signs in there. So 7 is actually -7 on the end. Okay, get the idea. Like terms, well, they like each other. Exactly the same variable form, exactly the same b cubed or a squared, and that sort of thing. So let's have a look at this one. We've got 4 lots of x plus 3 lots of y plus x times y, take 3x. Oh, that one and that one look the same, mate. They are like terms. Okay, so they like each other. The others are all different from each other. They've got different combos of the pronumerals or the variables in there. Come down to the last couple here, a constant term. I think you could probably work out that that's got to be constant, mate. So it doesn't contain a pronumeral, doesn't contain something varying. So x could stand for any number, so that's going to be different possibilities in there. Y could stand for a number, pronumerals. What's a pronumeral anyway? Remember, that's what we're talking about in this presentation. An x cubed, so it's only 7 that doesn't change. 7 is always 7. 3x squared or 3x can be various things depending on the value of x. So that's not a constant term. What about a coefficient? So this time we're going to split an algebraic term up into the pieces that have got variables, the pronumerals, and the number out the front. So 4 lots of x, 4 is the coefficient. 2 lots of this variable term, 2 is the coefficient. Y cubed is variable. What's in front? It's missing, but it's really -1. So it's a coefficient of -1 for y cubed. How many of the little terms you've got making up the variable terms making up the overall expression? Okay, so a bit of language there, so we can work our way around what we're doing in algebra land. Okay, let's come down and have a look at some examples from Hayes and Harris there. So first of all, is this up here an algebraic equation or expression? There's no equal signs and so on. There's no equal signs, it's an expression. How many terms does it contain? Well, let's list them. 4y squared, -6x, 2xy, -5 and x squared. So you're splitting up the expression into its parts, if you like, and they're called terms. What about the coefficients? Okay, so here the coefficient of x, there's the x term, it's a number in front, so it's negative 6. What about the coefficient of x squared? It's a number in front, it's only 1x squared, so it's just 1. This people often find confusing when I just write something like y cubed. You've got to remember it's 1y cubed. We leave the 1 out, don't we? Okay, so just remember that one. The constant term, what's a constant term? Well, is there anything in here that doesn't contain a variable or a pronumeral? Yes, it's -5, so that's a constant term. Little bit of language so that we're all speaking the same language and on the same page in algebra land. I'd like you to come down and have a go at 4B from Hayes and Harris here. Question 1 to 5, and just getting used to the language now. So it's important to do all the questions here. So you get up to pace on this. Okay, so we'll have a look at the answers after we do question 6 here. There's question 6. Okay, so again, as you do a few in question 1, toggle forward to the answers and go back and check and make sure you're getting some right there. All right, let's look at the answers now. Okay, question 1 to 6. I hope you're getting some right. It's pretty basic ideas now, and doing lots of them. You're doing your practice lap running, if you like an athlete running around that oval, mate. That's going to make you very good and build up your skills. Let's go on, one small part left, and then I'll give you a rest. I hope you're getting some right. Okay, the next part is collecting like terms. And we've said that what terms are like each other, they contain the same variables to the same powers or indices. So here we are, 2 lots of xy, take 5 lots of xy, are like each other. But a squared, the square of a, take 3a, are unlike. Oh, well, because they've both got a in them, but one's got a squared. So you're talking about a different number, aren't you? What are pronumerals anyway? They stand for numbers. So this will stand for the square of a, and that'll be different from just 3 lots of a. When you square a, you get a different number, so you can't collect them up. They're not like each other. Okay, so here, when we collect up terms to make an expression simpler, that's called collecting like terms. So you might have 2a somewhere and 4a, and that's overall 6 lots of a. Just spelling it all out here. Or 2 dogs plus 4 dogs is 6 dogs. Okay? Just collecting up things that are the same, if you like. Collecting like terms. Expressions which are the same. All right, let's go and do some stuff here now. So here's another example. Simplify where possible by collecting like terms. Are they like each other? Yep, 5x. 7a take 3a, 4a. All right, 7 dogs take 3 dogs. What about this one here? -2x plus 3 take x. -2x take x. Ooh, directed numbers, number line work. Come over here, let's put our number line. Neg x. We don't know how big neg x is, mind you, but it's in the negative direction. Neg 2x further on will be down at neg 3x. Okay, we can collect those up because they're talking about the same quantity. 2 lots of it in the negative direction and 1 lot of it in the negative direction. We don't know what it is. X is a pronumeral, stands for a number, but we can say they are the same number wherever that pronumeral is in the problem. It's the same value. And then we can't collect up the 3. That's just has to stay by itself. It's 3 units. What about the next one? 3bc plus bc. You've got 3bc, and remember this means 1bc. So you've got 4 lots of that value bc. What is the value bc? We don't know. Depends on what b stands for as a number and what c stands for in the problem. Okay, getting the idea. What about the last one? 2x take x squared. You can't do anything with that. Why? Well, this is a pronumeral, x standing for a number, and here's the same pronumeral, but it's squared. So it will be a different number. When you square 2, you get 4. And when you square 3, you get 9. So we've got 2 lots of some number in here. Mine is the square of that number. Got to keep them separate. And they are unlike terms. They're not like each other. I hope you're getting the hang of it as we build up now. So let's have a look now at some exercises for you, and we'll finish shortly. So I hope you're not getting too tired there. We'll have these 3 questions. I think I can get them all on there. Okay. So just the same sort of stuff as we did in the examples. So have a go. And I want you to do every one of them, but build up your skills now. Okay, and we'll have a look at the answers. First 3 questions there. See how you go. If you get them wrong, go back and check them, and check with your teacher and with classmates. Okay, one little bit left, and we'll do another example here of working with pronumerals. What are pronumerals anyway? Okay, simplify by collecting like terms. So we've got a bit of a bigger bundle here. So let's go and have a look at it. We've got 3a take 2a. So let's put them together, and then the numbers together. 2 take 3. So we're positioning the terms next to each other, which are like each other. We've got lots of a, which is standing for some number, a's, and then we've got ordinary numbers. So 3a take 2a is 1a, and we don't put the 1 in front. And then plus 2 take 3, let's just watch this now. That's 2, and take 3, remember this would be neg 1. Working on our number line, we've got to build up those skills. Remember, maths learning is sequential and cumulative. You build up your skills in sequence, and you accumulate a whole toolkit full of skills. Okay, so here we are. We identified that 3a and neg 2a were like each other, lots of a. And these two numbers were like each other because they were just ordinary numbers. What about this critter up here? Let's put it together now. X squared take 2x squared, put them next to each other because we spot they like each other. And then neg 2x plus 3x. Okay, so now we'll take a closer look. 1x squared take 2x squared is neg 1x squared. Let's check that dude out now. Here we are. We've got x squared, let's say it goes to there. Neg 2x squared will be down at neg 1x squared. Just remember, what are pronumerals anyway? They stand for numbers. So you can work with them on the number line in the same way as you worked with other directed numbers when you first found out about the directed numbers on number lines. Okay, what about neg 2x plus 3x? That'll be plus x. Let's do that as well. If we went neg 2x to the left there, and then plus 3x, oh, you'd be over on the other side by plus x. That's what we're doing now. So just keep in mind the steps. First of all, group up the terms that are like each other. Okay, those two bundles, and then try to combine them, collect them up. Okay, you want to have a go? Here's the last exercise, question 4. I want you to have a real go at this one now. Try and collect the terms up next to each other, and then add or take them away, remembering the directed line, directed numbers now, that earlier stuff. We've got to do it with our pronumerals. Hey, what's a pronumeral anyway? It stands for a number. So we can do directed number work with those pronumerals, those letters. Well, same thing, they're only standing for numbers. Okay, pause it, have a go, and I'll show you the answers now. Okay, so there's question 4, and that brings us to the end of this presentation. Hey, you've learned a bit now, haven't you? You might want to go back and check your skills there and make sure you're confident with all the language and stuff that we're doing. And I'll catch you in part 2 where we build up our skills. Cheers for now.